Hi everyone. In today's lesson, we are going to begin our study of probability relationships between events. Up to this point, we have worked with basic probability calculations. Now, we are going to take the next step and examine what happens when more than one event is involved. Here's the big question we're trying to answer. What happens to probability when two events occur together? To answer that question, we'll start with a very important idea called independent events. And we'll learn how independence allows us to calculate probabilities involving the word and. Let's get started. Let's think about a simple situation. Suppose I flip a coin and get heads. Now, I roll a die. Does the result of the coin flip change what number appears on the die? Of course not. The die has no idea what happened with the coin. The two events are completely unrelated. That idea leads us to our definition. Two events are called independent if the occurrence of one event does not affect the probability of the other event. Notice the key phrase, does not affect. If knowing the result of one event gives you no additional information about the other event, the events are independent. Let's look at some examples. If you flip a coin and roll a die, those events are independent. If you draw a card, replace it, and then draw another card, those events are also independent. Why? Because replacing the card restores the deck to its original condition. The second draw is unaffected by the first draw. However, if you draw a card and do not replace it, the second draw depends on what happened during the first draw. In that case, the events are dependent. Be careful here. Students often focus on whether the events seem similar. That's not what determines independence. The question is, does the first event change the probability of the second event? If the answer is yes, the events are dependent. If the answer is no, they are independent. Let's work through our first example together. Event A is flipping a coin and getting heads. Event B is rolling a six-sided die and getting a 4. Take a moment and think about it. Are these events independent or dependent? Pause the video if you'd like to decide before we continue. Now, let's analyze it. Does getting head on the coin flip change the probability of rolling a 4? No. The coin result has no influence on the die. Likewise, rolling a 4 does not affect the coin flip. Since neither event affects the other, the events are independent. Now, let's start on example 2. Event C is drawing a king from a deck of cards without replacement. Event D is drawing a queen from the same deck immediately after. And we want to know if these two events are dependent or independent. Let's think carefully. The phrase without replacement is extremely important. Suppose the first card drawn is a king, and that king is removed from the deck of cards. Now, there are only 51 cards remaining. The composition of the deck has changed. Because of that, the probability of drawing a queen on the second draw is different than it would have been before the first draw. The first event affects the second event. Therefore, these events are dependent. Now that we understand independence, we're ready to learn how independence helps us calculate probabilities involving the word "and." Let's think about what the word "and" means. Suppose I ask, what is the probability of getting a tail and rolling a 3? Both events must occur, not one or the other, both. Whenever independent events must both occur, we use multiplication rule. The formula is probability of A and B equals probability of A times probability of B. Let's see why this works. The probability of one event happening is represented by P of A. The probability of the other event is represented by P of B. Because the events are independent, we multiply the probabilities together. And this formula only applies if both A and B are independent. If A and B are dependent, we'll use a different formula. Example 3. A coin is flipped and a die is rolled once. What is the probability of flipping a tail on the coin and rolling a 3 on the die? So, we want the probability of getting a tail and rolling a 3. Let's identify each probability. First, I want to find the probability of flipping a tail. When flipping a coin, the total number of possible outcomes is 2 because you can either get a head or a tail. So the probability of getting a tail is 1 out of 2. Next, we want to find the probability of rolling a 3 on the die. A die has a total of 6 possible outcomes. So the probability of rolling a 3 is 1 out of 6. Since the two events are independent, we multiply them to get this probability. So we'll take 1/2 multiplied by 1/6. Which is 1/12. And the question is asking for decimal rounded to 4 decimal places. And that is 0.0833. Now, let's look at example 4. Suppose 92% of people have cars. 3 people are randomly chosen. Find the probability that they all have a car. So, the probability for one person has a car is 92%, which is 0.92. Because the people are randomly chosen, we'll treat these events as independent. And the word all means and. Person 1 has a car, and person 2 has a car, and person 3 has a car. So we use the multiplication rule. We take the probability of person 1 has a car, multiplying by the probability of person 2 has a car, multiplying by the probability of person 3 has a car, which is 0.92 times 0.92 times 0.92. And that equals 0.778688. The question asks for a percent, so we are going to convert this decimal to a percentage by multiplying by 100%. And that is 77.8688%. Now, the question asks to round to the nearest hundredth of a percent. So nearest hundredth means 2 decimal places. So this is my percent, and I want 2 decimal places. And that is 77.87%.